it's Miss McDowell here again with your division of decimals review. So I have your warm-ups here in case you would like to go through those. Again, we also have the warm-up video for you to go through them with me, but we are going to jump right into our content. So the goal for today's particular lesson is today we will review how to divide decimals using standard algorithm. So just reviewing that concept of using the standard algorithm to divide decimals. And then the reason we are doing this is to understand the difference between dividing whole numbers by decimals and decimals by whole numbers. So how does standard algorithm or the process or the steps that we use to solve change based on if we're dividing the whole or if we're dividing the decimal? And then also so that we can know how to solve for decimal division problems involving remainders. So sometimes our answers don't go in perfectly evenly, and how can we kind of make sure that we're still getting the correct or most correct answer we can when we are solving with remainders. So here I have this particular equation, which is 5 3/10 divided by 4. Before we actually dive into this one and solving this one, we're actually going to talk a little bit about it and how an estimation or estimating what our answer could be can actually get us even closer to what our answer actually is, or help us reason whether or not our answer makes any sense. So I'm thinking about 5 3/10, and I'm thinking about rounding that number. The way I would actually round that particular number is I would round it down to 5. So I would round 5.3 down to 5, and then I'm going to leave 4 where it is. So if I'm thinking about like a rounded equation, and I'm just thinking about how many times can 4 go into 5? Well, I know that it can go in one time, so I know that my answer is going to be at least one whole, right? But I know that also when I'm looking at the number 4, I know that my answer is probably going to be somewhere around 1 2500ths. And that's because when I'm thinking about the number 4, there are 4 2500ths little chunks in 4, and so, I'm sorry, in 1, and if I only have 1 left over until I get to 5, then my number is probably going to be somewhere around 1 2500ths. So if you're thinking about how many times can 4 go into 5, it can go in once, and then how many do you have left over? Well, you only have that 1 left over, and in that 1 left over, there are 4 25 little hundredths chunks, and so I know that my answer is probably going to be somewhere that's just a little bit more than 1 2500ths, and that's because 5 3/10 is just a little bit more than 5. All right, so we're gonna go and actually we're gonna go and actually solve this problem and see if that gets us, or see if our estimate is close to our answer. All right, so remember, your dividend goes inside your house, okay? So the first number goes inside your house, and your divisor goes on the outside. So I have written here again 5 3/10 being divided by the whole number 4. So now, because my decimal is only in my dividend, I actually just carry my dividend or my decimal point straight up, okay? Now I can just think about it as if I'm doing how many times can 5 go into 53? So, or 4 go into 53, excuse me. So 4 going into 5, it can go in 1 time. 1 times 4 is 4. I subtract and I get left with 1. All right, I'm going to bring down my 3 like regular division, and now I'm thinking about how many times can 4 go into 13? Can go in 3 times. 3 times 4 is 12. And then I'm left with 1 again. Now remember, when I get here, I can't just stop. Okay, I'm going to add a 0 up here to kind of help me keep solving because I need to go all the way to my thousandths place, okay, if I can. So how many times can 4 go into 10? It can go in twice. 2 times 4 is 8. I subtract and I'm left with 20. Again, I'm still not at my thousandths place, and I still have a remainder. And remember, we can't just stop here and like write this remainder as an extra part. We actually have to make sure we use it in some way and make it more meaningful. And so I'm going to add another 0 and just keep going and carry that 0 down. How many times can 4 go into 20? 5 times. 5 times 4 is actually 20, and so my equation actually stops right there. All right, so I know that 5 and 3/10 is equal to 1 and 325 thousandths, okay? So now when I'm looking at this, we need to go back and say, hey, do we think our estimate made sense or was logical for what our answer actually ended up being? And our estimate did make sense. We talked about how we thought if our estimate was 1 in 25 hundredths, that our answer would be fairly close to 1 in 25 hundredths. Well, 1 in 325 thousandths is fairly close to 1 in 25 hundredths. And also, it is just a little bit more like we said it would be because we ended up rounding the 5.3 down. All right, we're going to look at another one. With this particular problem, we actually end up rounding the decimal down again. And so when I'm thinking about this one, I'm thinking, hey, I know that with this, I would usually round 51 hundredths up to 1 whole, but I know that 51 hundredths is a lot closer to 1/2. And so I'm just going to kind of keep it at 1/2 and not actually make it a whole in terms of estimating. So what I can kind of think about this one is this is really close to 9 divided by 1/2. Remember, 1/2 can be written in many different ways, okay? It's just the way you're choosing to think about it. And I know that when I divide a whole number by a fraction or by 1/2, what I'm really doing is multiplying by 2. So when I think about this is actually going to give me 18, right? Okay, if I did keep, change, flip, I would end up getting 18. And what I'm doing there is really just multiplying my whole by 2. And so I know that my answer is probably going to be somewhere around 18. And so if my answer is not somewhere around 18, I know that I've done something wrong, okay? And we're going to go ahead and actually solve this one together. So again, the front number goes inside your house. It is your dividend, the number you're dividing into or splitting up. And then it's being divided by your divisor. So your second number goes on the outside. Now that I have decimal on the outside or a decimal in my divisor, I need to shift it out to make it usable. So I'm going to shift it out 1, 2. Whatever you do on the outside, you have to do on the inside. What I really did there was shifted it twice and multiplied by 100. So I have to multiply 9 by 100 as well. Okay, I'm going to rewrite this because remember, this would end up looking like this. So now that I can just think of this equation as how many times can 51 go into 900. I'm actually going to rewrite it again, just so that I have more room to solve and show you how to solve. Okay. Oh, 900 goes in my house, and I'm dividing it by 51. Okay, I'm going to go ahead and carry my decimal up just in case I end up needing it, because remember that decimal is technically still right after my ones place. So now how many times can 51 go into 90? Well, I know 50 times 2 is 100, so it can probably only go in one time. 1 times 51 is once. And so when I do that, I end up being left with 39. Okay? Now I know that 1 was correct because 51 cannot go into 39. I have this 0 here, so I'm going to go ahead and drop it down. Now I'm thinking, how many times can 51 go into 390? I don't know my facts of 51, so I am going to go off to the side and try some out. Let's try 7. I don't know why I picked it, but you can pick any number, really. All right, so 1 times 7 is 7, and then 7 times 5 is 35. So that makes sense. That actually meets the mark, but maybe it can go one more time. So let's see. Oh, sorry. Not what I meant to write. 51 times 8. Let's see. Nope, and that is going to take me over the 390 mark, so I know I can only go those 7 times. 7 times 5 is 357. I'm going to subtract, and then I end up being left with, let's see, 33. All right, I can't stop here, though, because I still have some left over, and I need to add some zeros. I'm not at my thousandths place. So I'm going to add a 0 and drop it on down, okay? Now, how many times can 5 go into 330. So it can't go in 7 times and it can't go in 8 times. I have a feeling it's just 6, but we'll go off to the side to check and make sure or figure out what that answer to that equation is actually going to be. And that is right where I need to be. So 6 goes up top, and then I bring it on down. And then I end up being left with, let's see, 24. All right, I'm still not at that thousands place, so I have to do it yet again. Drop my 0 down. All right, I know it can't go in 6 times. Let's see, let's just try 4. Let's see if 4 works. And what 4 gets us. All right, I think 4 is where I need to be, because if I added 51 to 204, it would push me way above that 240. And so 4 times 51, and then 204. When I subtract that, I end up being left with 36, which I'm just going to write off to the side over here because I'm running out of room down below. So I'm going to write 36 off to the side. And then again, I'm dropping down a 0 and adding it to my 36 because I'm still not at my thousands place. So now I'm thinking, how many times can 51 go into 360? So I know that it could go into 357 7 times. And so I bet it can go in to 367 times. Oh, sorry. I wrote that in the wrong spot. I'm going to turn that into a 5. Excuse me. All right, and I end up being left with 3. All right, I don't have to go any further. All right, but if you did, it's kind of interesting. If you added another 0 here and turned this into a 30, your next number would actually end up being 0 up there. But it would keep going after that. It would just become a 300 and then keep going. But I'm going to stop right there, and I'm now going to take this answer and see if this answer, 17 and 647 thousandths, makes any sense with my estimated answer, which I think it does make quite a bit of sense, okay? So when I look at this, I estimated 18 because I know that 9 being divided by 51 hundredths is very close to just 9 being divided by 1/2. And when you divide a number by something that's not equal to a whole or by 1/2, it's just like you multiplying it by that number. And so it's just like me saying 9 times 2. I know that 9 times 2 is 18. And look at there. My answer here is just a little bit less than what I estimated. So I know my answer makes sense. And that's because I was dividing by just a little bit more than 1/2. Okay. So just know that you can use estimation strategies to kind of help you figure out if your answer is logical. All right, we're going to move in and do 2 word problems together next. All right, Chris spent $16.75 at the grocery store. She bought 2 cards that each cost the same amount. She also bought Tide Pods for $9.25. What is the cost of each card? So here we have the equation. Now, this is a multi-step, so what operation should we do first? We're only looking for the cost of the cards, but we have the cost she spent total and the cost she spent on some other Tide Pods. So we know that we're going to need to subtract the cost of the Tide Pods first, and then we can divide to figure out what one individual card is worth. All right, again, we're going to look at estimating. So here, I know that that's $16.75 or 16 75 hundredths is really close to 17. And then that $9.25 that was the cost of the Tide Pods that I'm subtracting is really close to 9. So I'm just going to round those, and then I'm just saying, hey, 17 minus 9 gives me 8. Well, Chris bought 2 cards, and so she's dividing 8 by 2, which would equal 4. So I'm assuming that our answer is probably going to be somewhere close to 4, but we'll find out. All right, so here was my first equation. Remember, the Tide Pod cost that $9.25, and I really only wanted to know what the price of one card was, so I needed to get rid of the cost of the Tide Pods to figure out what the cost of both cards were to then figure out the cost of one card. So I'm going to solve this off to the side with you. I have 16 and 75 hundredths, and I'm subtracting 9 and 25 hundredths from that, okay? Remember, when you're adding and subtracting, unlike multiplying, you do need to line up your place value, okay? And so needing to make sure that those decimal places are as lined up as possible, all right? And I'm going to go ahead and line it up and drop it down, and now I can subtract. 5 minus 5 would leave us with 0. 7 minus 2 is going to end up leaving us with 5. And then I cannot take 9 away from 6 right now, and so I need to not borrow, but actually take. And so it's really 16 minus 9, which will leave me with 7. So I know that 2 cards cost $7.50. However, I didn't want to know the price of 2 cards. I wanted to know the price of 1 card, okay? And so now I'm actually going to end up having to take that $7.50 and I'm going to split it between 2, okay? So I'm actually going to divide it between 2. So I have $7.50 or 7 5/10 being divided by 2. All right, and so now I'm going to show you how you would actually solve that. All right, so again, my decimal here is only in my dividend, or it's only on the inside. So all I have to do is carry my decimal place straight up. Okay, I don't have to worry about shifting it because I know my facts of 2, so I don't have to shift it out or anything. So now, how many times can 2 go into 7? It can go in 3 times. 3 times 2 is going to end up giving us 6, and we subtract and we're left with 1. All right, now how many times, 2 cannot go into 1, so I know that this 3 is correct. I went into 7 the right amount of times, the correct amount of times. I'm going to drop down my 5, and now I'm thinking, how many times can 2 go into 15? 2 can go into 15 7 times. 7 times 2 is actually 14, and so again, I am left with 1. I can't just stop there, though, okay? I have to keep going because in terms of this problem, I'm actually talking about money, and so I want to know if it's going to be 70 cents or more than just that 70 cents left over, and so I can't just leave this 1 here and act like it doesn't exist. So I'm going to add a 0, remember, and just drop it down, okay? Now I'm thinking, how many times can 2 go into 10? It can go in 5 times. 5 times 2 is actually 10. And then look at there, it stops right there after my first adding of a 0. All right, so I know that Chris spent $3.75 on 1 card, which honestly is kind of a bargain because I just bought my mom a Mother's Day card and I think it was like $8 or something. So she did a pretty good job buying cards. But let's look and see if our estimate from before actually made any sense. So each card cost $3.75. We estimated that each card would probably cost around $4. So yes, our estimate makes sense and is logical, and our answer is actually logical because $3.75 isn't a whole lot less than $4. All right, we're going to do one more together and talk through it, okay? So Walmart sells 12-pack of Coke for $9.39. The store is having a sale for 75 cents off the Coke. What is the cost of the individual Coke after the price is reduced, okay? So first, let's estimate. We know when we think about rounding $9.39, we would round that down to 9. And then when we actually think about rounding that 75 cents that's off, or that's like they're taking off the price of the Coke, we would round that to $1, which means initially our equation would be 9 minus 1, which would give us 8. And then we're simply thinking about, okay, I'm splitting up 8 divided by 12, okay? How many times can 12 go into 8? Well, it can't, but you know that if you put that I actually wrote that as an equation, so I'll show you. If you actually wrote that as an equation, remember, we would end up writing it like this as a fraction to help us make more sense. And if you simplified that down, you would end up getting 2/3. And so they're going to ultimately be, each price of a Coke is going to be around 2/3 of $1. Well, if I think of what's 2/3 of $1, okay, well, there's 100 pennies in $1. 2/3 of $1, remember, of is multiplying. And so here, let's see what happens here. I'm going to end up with 200 being divided by 3. Well, how many times can 3 go into that 200? It can go into 26 times. Subtract 2. And it can go into 26 times again. 18, and I would just keep going. It would keep going and keep going, okay? So it's actually, because I was talking 200 cents, it's 66 cents, okay? Because $2, 200 pennies. So our answer should be somewhere probably around 66 cents based on our estimation. All right, we're going to see if we are correct, okay? So here we have our initial equation. Remember, the total price of the Coke was $9.39, but it was 75 cents off first. So we have my $9.39, and I'm subtracting 75 cents from that. Remember, when you're adding or subtracting decimals, you need to line them up and make sure your place values lined up. All right, so I have them lined up. And now that they're all lined up, I'm going to drop them down. All right, and so then I can start subtracting. 9 minus 5 is going to give me 4. I have to take away from my whole here. 13 minus 7 is going to end up giving me 6. And so I'm left with $8.64. That's how much the cost of all the 12 Cokes were after I took the 75 cents price off, okay? But now I need to figure out, hey, what is the price of just one of those Cokes? So I'm actually going to take that $8.64 and I'm going to divide it by 12 because I'm splitting it across 12 different Cokes, okay? But I only want to know the price of one Coke. So now I'm going to show you how to solve that particular problem. Again, I don't have a decimal in my divisor, so I'm just going to carry my decimal straight up. Now I'm thinking about how many times can 12 go into 86. All right, well, 12 can go into 86 when you think about it. It can go in 7 times, actually. If you don't know your facts of 12, you can also go off to the side and just try, like we could try 6. Can we get any closer with 7? We can, and it gets us to 84. We can't get any closer to 86 than that. So my 7 goes here. 7 times 12 is that 84. I'm going to subtract, and I'm left with 2. Okay, that also tells me that 7 is right because 2 is less than 12. I'm going to carry down my 4. How many times can 12 go into 24? It can go in twice. 2 times 12 is 24, so this is one of those nice ones that we get to just stop there without adding any of our zeros. But now we know that the price of each Coke is 72 cents after that discount, which is pretty cool. And so now we can think about it as, hey, did our estimate make very much sense? Yes, it did. We said that it would be about 2/3 of a dollar for one Coke, and that's 66 cents. And so 72 cents is fairly close to 66 cents. So our answer is logical. It makes logical sense, okay? All right, so now all you're expected to do now is complete the dividing decimals review Google form, and you can also do it in PDF form if that works better for you. And then if you have questions, you can always attend your teacher's office hours, okay? I know that some people have been struggling with adding the extra 0. Just make sure if you have any left over and you're not at the thousands place yet, you can't just stop there and you can't just add it as a remainder. You have to keep going and adding the zeros until you get to the thousands place or until you're left with 0 at the end. And we know that you can do it. All right.